Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with Learnbay.co. Happy learning!
Here it is based on because theta is the variable not x. Okay. So now where theta I are basically the parameters of hypothesis. Now the idea is biggest question is how to choose the correct parameters. Okay. So the purpose here is, or the idea of cost function is, okay, cost or error. What is error really? Come on, anyone. What is error?
Deviation from actual and predicted.
Very nice. Deviation. A lot of people also just call it deviation, and they are right. Deviation from. So now y is given. So because of data, we know what is y actually. The question is, with your prediction, how much difference you will show? Okay. So now this is called error, but the problem is you cannot use this error. Why? Okay, from now onwards, y actual will be represented by y and y predicted will be represented by y hat. Okay, remember this. Y hat will be y pred. I will not write the whole thing or again and again. And y will simply means y actual. Got it? Okay, now what is the problem if I wanted to get total error? Because there are a lot of points, so total error, what could be the problem with this equation?
With multiple points, it can sum up to 0.
Yeah, it can be so well balanced that basically the total sum can come 0. So I think we have already had this discussion. So basically I'm just going there that here, let's say we go with MSE for now. Okay, what is MSE?
Mean squared error.
Very good. Now MSE can be 0 or positive only. Agree? So the task of any kind of machine learning algorithm, if you remember, is to better the performance measure. So if you want to do better the performance measure, then MSE should tend to 0. Mean squared error should tend to 0. Okay. Because you want least error, so you want to minimize this equation. Okay, you want to minimize theta, as many thetas you have, yi minus hi of x. Basically that y hat is nothing, it's just the hypothesis. Okay, or you can try to minimize this one. Okay, so let me show you the figure first. So this is the idea, guys. Okay, let's do this. Let me ask you this question. Okay, what I will do is I will start from, let's say, here. Okay, now as I will keep moving, just you guys can see the line that I'm moving here. Okay, I will draw different lines for you guys. Okay, okay, tell me which line is the best fit. or does looks like which would have the least error?
Maybe red.
Sorry, which one?
Maybe red.
Red. Okay. Okay, good. But how would you do it? Like, okay, it might look like it, but how would you really calculate it?
The predicted line is red, and we know the actuals from the points. So the distance.
So basically, Pallavi says line closest to maximum number of points. That actually is very good. But again, how do you calculate this? The idea is fundamentally again to reduce this error between the predicted and the actual, right? So our target is, see these faint lines around it. Basically, we have tried to show the straight deviation. Okay. So now the target is in totality, can you draw a line which can reduce these points or these deviations that you are looking here to the lowest, and so that their sum of squares or their mean is the lowest deviation that we can get. So we will take this idea and we will move forward, and basically we will come up with the equation, which is again nothing, it's just an equation of MSE. Now cost function in machine learning is usually represented by j of theta, and here there is an extra 2, and I will show you why it is required. Even if you reduce 2, it doesn't matter. 1 by 2m y hat is the y prediction minus y actual squared. Okay, so this is MSE, mean squared error. So now this might have been a question. I think when I covered error in statistics, some people had asked between MAE and MSE, which is the better one, remember? Mean absolute error means squared error, which is the better one. So at that point, I did not give you the answer. I told like in later times it would be much clearer. Even mean squared error has slightly more complexity to calculate compared to mean absolute. We will prefer MSE, and I will show you why. Please note down this equation because you might have to solve something. Okay. Tell me something. Okay. If you have two variables, y and x, and let's say there is a second degree in this here. So what kind of shape it would take? The overall equation, what kind of possible shapes it could take if there is one variable? Of course, you can have multiple variables and try to solve that.
Parabola.
Very good. You will get a parabola. Now, what is the property of parabola? Parabola might look like this. The idea is usually there is one point which is the lowest point usually. Okay, and I will show you what to do with this lowest point and why this is beneficial for us. So we are going to use a technique to find the lowest point, and that is called gradient descent. Because we are going toward downward, we are calling it descent, not as a ascent. Okay, So the idea is to move towards the correct direction while approximating the parameters theta I. So the idea is at some point you will find the loss. This is, let's say, a loss function j theta. So you have to find the lowest point in here. Maybe the lowest point is here or somewhere. Okay. Now the problem is, how do you do it? Okay. What does gradient means in mathematics?
It's a direction.
Slope.
Slope, very good. How to calculate gradient?
Tan theta.
Tangent.
Gradient, and some people likely say slope, okay, or some people also call it tangent. Okay. What is the purpose of gradient? Why you are using gradient? So gradient value will give you the magnitude, of course, as well as direction. I will explain how. How is gradient calculated? Some people rightly said tan theta, okay, or you could basically do a differentiation.
I'm not sure the differentiation. So normally is you go to the ordinary differentiation or the partial differentiation.
Sorry, what did you just say? Can you just speak up a bit louder?
About the gradient calculations. So typically, normally mathematics use the partial differentiations, and does the computers allow in terms of the machine learning to do the partial differentiations to solve this gradient descent problem?
Yeah, fundamentally gradient descent would be partial differentiation, and computers can, okay, computers cannot exactly do differentiation, means theoretically they can't, okay, but they can simulate differentiation. So they can take a very small time step and try to do differentiation time step by time step, okay. Of course, because they're digital machines, so of course they cannot really do a like total differentiation, because they still have to deal in quanta, okay. But they can, it can be simulated, and SciPy has packages for differentiation as well, okay. Yeah, it would be mostly partial differentiation idea anyways, okay.
Yep.
Okay, so let me show you a figure, and let me explain step by step what goes on. Okay guys, so the idea is we have to plot something. So okay, replace this w by theta, okay, theta 1 or something, and here remember it is j theta 1, okay. So loss plotted against the parameter. Let's say it will look like a parabola. This is not a great looking parabola, but still. Now initialize the weights. So initialize the weights is you take a hypothesis and you say some value of theta 1. Let's say initialize as 5. Again, random initialization, guys, okay? X. Okay? So basically you have to calculate the loss, okay? So j theta or theta 1. So let me show you. So j theta 1 would be, what would be j theta 1? Y hat minus y squared. Okay, so basically in this form you understand this will look like a parabola, okay. Because of random initialization, let's say it has been started here, okay, it appears here. Now where is the lowest point, guys? Can anyone point to me? This is the global cost minimum, at least for this equation, okay. This is the minimum, j min of that w, or basically theta. Now from here to here, how would you reach? Now remember, the change will happen only on theta 1 level. So let's say this is 5, and let's say the actual value is 2, okay. So how would you reach from 5 to 2?
integrate?
No, why would I integrate? I don't want the area. Come on.
You choose the theta initial value problem, and then you step by step you change
Step
the
by
theta.
step. Yeah, basically the idea is you initialize here. Let's say theta is, let's say theta 1 is 5. Okay, so the equation looks like as y hat is equal to 5 dot x, right? Let's say there is no theta naught as of now. Okay, now but the actual equation is y is 2x. Okay, so what would be your loss? Can anyone tell me the loss? Basically the equation, there is, of course there are a lot of one, but you can simply understand that y hat minus y squared. Okay, this is the loss, or there might be an x as well. Okay, this will be, no, sorry, loss is this much only, because there is, of course it is already included here, so it is there. Now the idea is how to minimize this. So the target is to minimize this one. So to minimize this one, what you do is, it's a very clever trick if you think about it. Remember, these are approximation techniques. Okay, so fundamentally what you do is, first you take a gradient of j theta. Now I'm using a partial derivative here, as you can see, because this could be a lot of thetas, so we will use a partial derivative. Okay, so by using the partial derivative, let's try to solve this. So what is j theta, guys, currently? Or if I were to expand it, then 1 by 2m into the y hat is, come on,
5x minus 2x.
so am I correct? So basically the equation is in terms of theta 1 as well as theta naught. Of course there could be a lot of thetas here, but the rule will remain the same. That is what I'm trying to say. What if you wanted to take a partial derivative of theta 1 comma theta naught with theta naught first? What would be the output here, guys? Anyone? So 1 by 2m is 1 by 2m. Let's go step by step. 1 by 2m is out. There is, you cannot, you should not, you don't have to differentiate this. Now this part has to be differentiated, right? Squared. So the first differentiation would be in terms of
Theta naught.
no, you have to be careful. It's going to be chain differentiation now. Remember chain differentiation or chain rule? Now remember, y will behave like a constant here, guys, okay? Because y is known, y is not a variable yet. So now you want to just differentiate in terms of theta naught. So theta 1, okay, what happens when you take a partial derivative? Theta 1 will also behave like a constant. Agreed?
Yes.
So remember, x and y were not your variables. X and y were your constants, because it is coming from your data, so you already know the value. Okay, the only variable in the whole equation is theta naught. Okay, so how would it look like? Okay, so first step, what would happen here, guys? Can anyone tell me?
Yeah, 2 into the bracket. Right.
So basically you will get something like this one, and this is why I told you we will be able to kill this. Okay, so now here you have the equation. Okay, so basically because this equation is in terms of theta naught anyways, Basically, you can substitute it as like overall as the final one will come as like 1 by m if you wanted to understand, and basically you will be able to get it as like again y hat minus y. That's it. Okay, there is summation sign, of course. Means I have just reconsidered it back. Okay, if you are taking in terms of theta naught.
Sorry, where's the numerator 2 come from?
It was approximation that I took earlier so that I can cancel this one out later. Okay, this was taken as a constant. Putting this constant doesn't changes much. Okay, but it just cancel out the, because when you will do a differentiation, 2 will come here, right? So it will just cancel both of them out.
Yeah.
Okay, now.
Sorry, can you please explain the differentiation? Yeah, because it's.
Okay, so tell me, what is the answer?
(2x).
Okay. All right. So that's what the trick was over there. Basically, I took the j theta or theta 0. It is defined in terms of two variables, theta 0 and theta 1. And first I did the partial derivative related to theta 0 only. Okay. So the form which comes is 1 by m summation. Now, if I wanted to keep this in the same form like it is already, this is what you are going to get. But what about the other one? If it was theta 1, where did this x come from? Because if you will remember, if I wanted to do a partial differentiation in terms of theta 1, something like this would happen. So this is the equation. So let's say you wanted to do this part. So while you are differentiating this one 1 by 2m y minus y hat minus y. Okay. Okay. Now the variable which contains theta 1 is y hat. And so of course you can do this chain rule. I will just take a shortcut here just to solve this problem. So if you remember, y hat will contain theta 1 x1 plus theta naught. Now theta naught is a constant here because of the partial derivative. But remember, theta 1 has an x1. So what will happen if I do this one? So forget about this part. This will basically become 0. What would be the output? Can anyone tell me?
x1.
Very good. This is where the extra x1 or x is coming from. So this equation can be written later as 1 by m into summation y hat minus y x1 or x1, correct, or x, let's call it x. And this is the generalized form that your partial derivatives will give you like this. Now remember, what you just got is the gradient. This is the gradient form. Now what you have to do is you have to update. So let me show you the equation. Okay. So you can see basically this is the part of the update, or basically this is what. So basically this is nothing but 1 by m summation y hat minus y. And this is nothing but 1 by m summation y hat minus y into x. Okay. So the idea is that step by step we are gonna update the thetas. So first theta 0, let's say, has to be updated. So with the previous value of theta 0 minus 1 by m with the gradient step, whatever the gradient has come, because gradient has the magnitude as well as the direction. Okay, and the equation was, okay, and theta 1, whatever the previous value of theta 1, sorry, there's a summation sign here, sorry. Is it complete? Is the equation, does this make sense, what I have just done?
Yes.
Now, the problem is, when you take a summation, sometimes it can become, and plus when you are multiplying by x, even when you are averaging it out, it still can become a very large value. So what happens is, or what ends up happening is, let's say you have a parabola, let's say you randomly started somewhere. So initially the step could be so large, the gradient, this might be the gradient, the step could be so large, and again when you take a gradient it would be very large, and it would take like a lot of time to settle down here. Okay, basically you have to move here. So you can see the step that you have taken is too large. So what you do is, to dampen this step, okay, we put a alpha here. What is alpha? Alpha we like to call learning rate. Now learning rate or a step size. Now it needs to be less than 1, guys. This is a kind of a requirement. Okay, it needs to be less than 1. So the some values that we take are like 0.1, 0.01, 0.001, sorry, 0.05, something smaller than 1, which basically reduces the step size. So rather than jumping directly, starts to go like this. Okay, so this gives the complete equation for the update of theta, right? And the idea is you keep doing it till no more changes happen in theta 0, theta 1, and then you stop. So let me show you how it will work so that you get the step-by-step idea. Please note down this equation. This will come in handy, both of them. Okay, so if we were to come with a small algorithm, go step by step. So first task is to separate the training testing if not done already. Now initialize random real numbers for parameters of hypothesis, means theta. Initialize a small learning num. Now this is an example. You can try and test with different alpha. Calculate the cost and loss function for all data points. Remember all data points, but it means training data. And average them. Okay, average is 1 by m. Then shift the value of parameters to a local optimum step by step. That is called gradient descent. Repeat till you hit optimum point, means when the loss is at minimal. If it takes too much time, initialize or reinitialize the experiment with different values and run again. Sometime it can happen your initialization might be so wrong that it might not ever reach to the some kind of minimum point or optimum point.